Hello everyone. In this video, we are going to discuss important questions of thermal science. Thermal science is a subject of IGNOU. The course code is BEY-001. ये सेमेस्टर 1 का एक सब्जेक्ट है जो कि हमारे कोर्स के अंदर आता है जिसका नाम है BSCAEY प्रोग्राम BSc अप्लाइड साइंस एंड इंजीनियरिंग. ओके, सेमेस्टर 1 इग्नू के लिए है ये इंपॉर्टेंट क्वेश्चंस और ये सारे क्वेश्चंस आपको इंग्लिश में प्रोवाइड होंगे. आई नोटिस द स्कैरसिटी ऑफ द इम्पॉर्टेंट क्वेश्चंस और गाइडेंस into this subject, so I decided to make a video of important questions. So I'll provide 3 videos of this subject in which this video will contain all the important questions of the book. Then I'll provide a second video in which we will have chapter wise important questions, and at last we will see 15 most important questions from all of the book. Okay, so let's start with the first important question of the series. Okay, so the first question is, discuss about the 3 in detail: work, heat and thermal cycle. Second, describe Ball's and Charles' law and further derive the equation of state. Discuss fire and water tube boilers and bring forth the differences between them. Fourth question is, describe a velocity compounded impulse turbine with a neat sketch. Enlist and explain the 2 primary classification of a condenser to be used in a power plant. Also discuss steam surface condenser configuration. Derive the expression for efficiency in an Otto cycle. 7th question is, differentiate in detail between a 4-stroke and a stroke IC engine. Describe the combustor of a gas turbine with a neat sketch. Discuss some applications of the refrigeration and air conditioning systems. Describe the simple vapor compression refrigeration cycle in detail. What is thermodynamics and what is important to study it? Why it is important to study? Describe the law of thermodynamics and their importance. Define the term system, surroundings and boundary in the context of thermodynamics. Differentiate between intensive and extensive properties with example. 15th question is, what is thermodynamics equilibrium and what are the conditions required for it? What is the first law of thermodynamics and how is it extremely validated? What are the expressions for the first law of thermodynamics for different types of processes? Constant volume, constant pressure, isothermal, polytropic. What is the Kelvin-Planck statement of second law of thermodynamics? What is the cellular statement of the second law of thermodynamics? What does the second law of thermodynamics impact? How does the second law of thermodynamics impact the design and efficiency of heat engines and refrigerators? Explain why water is considered an ideal working fluid in thermal energy conservation system. Describe the process of superheating steam. What are its advantages? Explain the significance of the saturation temperature in the steam generation process. Differentiate between sensible heat and latent heat in the context of heating water to produce steam. Discuss the importance of Ts, temperature entropy and Hs, Euler diagrams in thermodynamics. Describe the constructional features of Landshire, Cochrane and Babcock and Wilcock boilers. Differentiate between fire tube and water tube boilers. Discuss their applications and operational advantages. Explain the significance and functioning of boiler mountings such as safety valves, pressure gauges and water gauges. Discuss the importance of boilers accessories like economizers, superheaters and air patchers. How do these components enhance boiler efficiency? Describe the classification of boilers based on fuel type, the construction type, application and steam delivery condition. 31st question is, explain the working principle of Rankine cycle in a steam power plant. Include the key component and their functions in the cycle. What are the effects of pressure and temperature variations on the Rankine cycle efficiency? Discuss with reference to decreasing condenser pressure, increasing boiler pressure and superheating of steam. Compare and contrast the simple Rankine cycle with the Rankine heat cycle. What are the advantages of incorporating reheating into the Rankine cycle? Describe the concept of regeneration in Rankine cycle. How does perfect generation influence in cycle's efficiency? Discuss the practical limitations in achieving perfect regeneration. Explain the operation and significance of steam nozzles in a steam turbine system. Include a discussion on the calculation of exit velocities and factors influencing noble efficiency. 36th question is, what are the primary components of steam surface condenser and their functions? Explain the operational advantages of maintaining a high vacuum in a steam surface condenser. Compare and contrast direct contact condenser and steam surface condenser. Discuss the various types of cooling towers used in conjunction and steam condensers. Describe the corrosion mechanism affecting steam condensers and their mitigation strategies. Describe the principle of first law of thermodynamics and its mathematical representation. How does this law apply to a closed system undergoing a cyclic process? 42nd question is, explain the difference between isothermal and adiabatic processes. Provide the mathematical equations grouping these processes and discuss their implications for work done by or on a gas. What is the significance of the Carnot engine in thermal science? Derive the formula for the efficiency of a Carnot engine and discuss how it is affected by temperatures of the heat reservoirs. Define heat transfer and mechanisms of conduction, convection and radiation. Explain how each mechanism contributes to energy transfer in practical applications such as a heat exchangers or thermal insulation. Discuss the concept of entropy in thermodynamics. How is entropy change calculated for different processes? And what does it imply about the direction of spontaneous processes in a closed system? Explain the Carnot cycle. Discuss the Otto cycle. Describe the diesel cycle and its efficiency calculation. What is Rankine cycle? Discuss the modified Rankine cycle. Describe 4 strokes of a 4-stroke Otto cycle engine and their corresponding piston movements. Explain the differences in ignition method between petrol engines and diesel engines. I know there is a lot of questions in this video. In this video we have 80 questions, but we have to consider this point that we are studying a subject belonging to science and this is very necessary to complete all the important questions. Otherwise, if you do not wish to complete all the 80 questions which are important, then you can just jump into the video of 15 important questions. Otherwise, at least once you should see this video to get an idea, okay, these are the important questions. So मैं ऊपर से भी एक आइडिया तो इन क्वेश्चंस का ले ही लूँ, क्योंकि एक साइंस के सब्जेक्ट के लिए इतनी नॉलेज इंपॉर्टेंट होती है फॉर द स्टडीज़ एंड टू क्रैक अ गुड एग्जामिनेशन. ओके, लेट्स स्टार्ट. 53rd question is, what is the purpose of governing mechanisms in an IC engine and how does the heat and miss method differ from the quantitative method? List and compare the advantages of two-stroke engines versus four-stroke engines. Define the following efficiencies in engine performance: indicated thermal efficiency, bar thermal efficiency, and volumetric efficiency. How do they relate to each other? Describe the basic components of a simple gas turbine power plant and their functions. Compare and contrast open cycle and closed cycle gas turbine power plants in terms of their operation and efficiency. 58th question is, explain the role of the compressor in a gas turbine power plant and how it affects overall performance of the plant. What are the key characteristics and advantages of using natural gas as fuel in gas turbine power plants? Discuss the impact of compressor and turbine efficiency on the overall performance of a gas turbine power plant. How do factors like entropic compression and expansion affect performance? Explain the concept and significance of the coefficient of performance in refrigeration and air conditioning systems. Describe the historical development of refrigeration. Mention key milestones and inventors who contributed to its evolution. Differentiate between refrigeration and air conditioning. Provide examples where each is used. Discuss the applications of air conditioning in industrial settings. Why is it crucial for certain industries? Calculate the refrigeration capacity in tons of refrigeration (TR) if a system removes 36,000 BTU of heat per hour. Explain the steps involved in the calculation. What is refrigeration and how is it defined in context of the refrigeration cycle? Explain the main component of a simple vapor compression refrigeration system and their functions. Describe the theoretical vapor compression cycle with dry saturated vapor after compression using TS and pH diagrams. 69th question is, what are the effects of varying the suction and discharge pressures on the performance and COP of vapor compression refrigeration system? How does the reserved Carnot cycle function as a refrigeration system, and what are its temperature limitations? What are the primary differences between primary and secondary refrigerants, and can you provide examples of each? How are refrigerants classified based on their safety considerations, and what are the implications of these classifications? Explain the significance of the critical temperature and pressure of a refrigerant and how these properties affect the performance of a refrigeration system. Describe the American Society of Refrigerating Engineers naming convention for hollow carbon refrigerants and provide an example of how a refrigerant is named using this system. Discuss the environmental impacts of refrigerants, including their ozone depletion potential and global warming potential. Why is it important to consider these factors when selecting a refrigerant? Explain the working principle of a vapor compression refrigeration system. Illustrate your answer with a schematic diagram and a TS diagram. Discuss the limitation of the Carnot vapor compression system when using vapor as a refrigerant. Compare dry compression and wet compression within this context. Last three questions are, describe the effect of evaporator pressure and condenser pressure on the performance of a standard vapor compression cycle. Use TS diagram to support your explanation. What is the significance of pressure enthalpy diagram in analyzing vapor compression systems? Explain the different regions of the pressure enthalpy diagram with an example. How does superheating of the suction vapor and subcooling of the liquid refrigerant affect the performance of a vapor compression refrigeration system? Discuss the advantages and potential drawbacks of each method. Okay, so this was our last question. I know there are a lot of questions. We have approx not. We have 80 questions in all. But the thing is, if you want to revise your book, all the chapters of your book, or you just want to go through all of the chapters in the book by the questions, you can go through these questions, find your answers, you have your own book, and all the best for your examinations. These all of the questions are important for your examinations, but I know 80 questions are a lot of questions, so I'll definitely cut it short to 15 to 20 questions, so that if someone is studying at the last minute of the exam, he or she will find the video informative. Okay, so thank you so much for watching this video.